Hey guys, Alex here again. I thought I might just give a quick update video on the whole supercharger upgrade for the Xterra, or actually going to a twin charge setup, because right now, as you know, it's turbocharged. So not much really to report other than showing the progress I've made with the supercharger adaptation itself. The Xterra is actually over here in the storage lift up top. It's February in here in Tennessee. Well, it's definitely warm today. The other day we had snow. And, there's really no point in driving the Xterra when it has no, doors, windows, or anything like that. So it's been up there for a little while. But with that said, it doesn't mean I can't be working on it and getting it ready for some fun activities. Anyway, so let's give a quick update of what I got going on over here on the bench. And then we're going to kind of talk through this. Now, here on the bench, laid out, we have the superchargers from the Xterra, right? Or the M122 supercharger and its intake manifold adaptation set. And then here we have my M122 and the work I've done to adapt it. Now I'll move to this conversation here in a minute. First, we're going to talk about the M62. Now, to start off here, I don't know the technical specifications as far as the output and the the volume that it pushes out. I'll have to read it up, and get it up on a spec sheet, Google or whatever. I don't have it on the top of my head. But for today, I just want to show you how everything is assembled and where we are with, what progress I've made and what the ETA is and when do I think it'll be installed in the Xterra. So that's what we're going to talk about today. So let's first talk about here on the stock setup. So right here, we'll start with this piece. This is the lower intake manifold for the VG33ER. Let's pause right there and talk about the VG series, the single overhead cam specifically. So for the Z31 and other cars from like 1983 up to like 1995, it was a VG30. And the VG30 is the 3-liter single overhead cam V6 from Nissan. We all know that if you're, a Nissan guy like I am. They went to the 33, which is a 3.3 liter from 96 up to 2004. There's a lot of changes, but minute footprint related, right? So meaning there are subtle differences to make things more modern in terms of adapting to newer vehicle standards, but yet you can mix and match components to make things compatible. So like, for example, in my Z here, which, I'm working on it, which will be another video. I probably will post that tomorrow. But this is my VG33. It's out of a 2004 Frontier. And the intake, for example, the lower intake is actually from a VG30. I was going to run the lower intake manifold from a VG33, but there was some challenges I had with the injector seating, and I'll explain that here in a minute. But my point is that with the single overhead cam VG stuff, you can swap things around a little bit to make things compatible with various setups, right? So, just saying that it's still a VG, it's still a single overhead cam, there's a lot of compatibility, there's things that line up, things that are kind of different, but just for conversation's sake, let's just focus on the VG33 that's, from the Xterra and Frontiers, and also, Pathfinders had them too. So, so as I said earlier, this is VG33ER stuff, right? The E stands for, well, let me step back. The VG is the engine class, the engine family of Nissan. The 33 stands for a 3.3 liter. Like, for example, a VG30 will be a 3 liter. And then the E stands for electronic fuel injection. And the R stands for supercharged. Whereas, the Z31, the VG30ET, the T would stand for turbocharged, right? And if you're curious, like on the Z32 stuff, the VG30DE stands for dual overhead cam electronic fuel injection, right? So DE, dual overhead cam electronic. And then obviously with the DETT, the TT would mean twin turbo. So once you understand the code, the engine family, it kind of makes sense. So this is the VG33ER lower intake manifold, and as you can see, it has these extra provisionings for the bolt pattern of the supercharger adaptation plate from factory. And if you look at the normally aspirated VG33E lower intake manifold, it's just the conventional 5 bolts, if I can count, geez. So if you compare this to a VG30 lower intake manifold from like a Z31 Maxima or whatever, these 33 lower intake manifolds actually flow better for two reasons. The porting, if you can actually see, it's pretty straight. I mean, there's a curve to it obviously, but it goes straight to the head pretty well, and that the port radius is actually consistent all the way throughout. On the early 84 through 86 lower intake manifolds, they actually, at some point, they kind of taper, and they're not as straight. They kind of do a little more of a curve. So these do promote a little better airflow. Whether or not that's going to be performance oriented, yeah, I mean, you might make a little more torque out of it, you know, with air moving faster, but it's nothing to be concerned about when you're having a build. Like, for example, going back to my black Z here, you know, I had the VG33, but I have the VG30 lower intake manifold from like an 88 or 89 VG30. Again, I had to run that for injector reasons. The VG33 uses injector and rails that are similar in design to the Z32. You know, Nissan keeping with the times as they, you know, progress forward with their technology. So I would have challenges with seeing the rails and my custom intake I made. So that's why I opted to keep with the VG30. I'm still making 838 wheel horsepower in that beast. So again, it's not really something of concern. I'm just stating a fact here is all. So moving on. So how this works is on the VG33ER and the Xterra and the Frontier for the supercharged models. This is your lower intake manifold, as we just said. This is your lower, you know, supercharger collection plate. I don't know what the exact term is. I just call it the supercharger adapter plate. And I'll actually throw 2 bolts on it and kind of get things mocked up here for conversation's sake. So we'll put a bolt here, and we'll put a bolt here. Nothing tight. All right, and so from there, you got the supercharger that, you know, there's a gasket in there. I don't have it fully on anymore because this is a takeoff. And the supercharger would bolt on as seen here. And again, I'm throwing a couple bolts here just to get things mocked up. Okay, so my impact over here. So this is the supercharger assembled on the collection plate going down to the intake manifold, the lower intake manifold, and then you got this weird elbow for the throttle body and all its various coolant and air regulator piping here. Definitely necessary for the stock application to have these. So normally, as you can see here, this would be put on there. Got this weird support bracket here. This is cast. This is actually pretty heavy with all the piping and whatnot, so that's why they have this support bracket. And then you have a couple studs up there to put the elbow. Now the only throttle body I have is currently on the vehicle, so that's why you don't see a throttle body, but this is clearly where a throttle body would bolt to, and here's a throttle body cable linkage up here. So here that is. Let's just kind of put that on, this spare mock-up VG33 that I have for when I do random welding stuff. So let's put that over there for a minute. I just kind of want to show you all what it looks like. I mean, if you Google, you can come across this as well. It's not like it's, you know, crazy new. But yeah, here's the M122 supercharger, you know, sitting on the VG33. No crank or anything like that. It's just a dummy block. But yeah, I mean, it looks cool as it is, even from a factory standpoint. Get a, you know, root style blower sitting on there. Let's put the throttle body elbow, just kind of give it some added spice. Then you can really see, if I can get that thing to go on, you can kind of visualize what it would look like when it's all done. There we go. So the throttle body would hang right about here, you know. So pretty cool. I like seeing different cool stuff that Nissan's done over the years. But yeah, I mean, that's it. I like it. It's just cool. These from factory on the 33, you know, the Xterra, they made about, you know, 205 horsepower, something around there, kind of similar to the VG30 ET. They also made about 200 horsepower. These put out about 6 to 7 pounds of boost. You know, I guess it's respectable from a factory standpoint, but the truth is this supercharger, the M122, was not a good pick for the VG33. If they had put an M90, man, that would have been cool. That would have been cool. The engine would have no problem supporting it. The motor itself is pretty reliable and pretty stout, but they chose a bad sized supercharger. You'll find that M162s are more commonly placed on 4-bangers. And if you compare like the Pontiac Grand Prix or the GTP, whatever they call it, they have the M90, and that's a V6. Granted, it's a 3.8 liter dual overhead cam. It's a little tiny bigger of a V6, but irregardless, they have an M90 on that, and it performs just fine. So I really think that Nissan should have put the M90 on there and then be less squabble about the inefficiencies of this. But again, like, this does make a world of a difference on a compared to a naturally aspirated Pathfinder or Xterra Frontier. The Pathfinder and Xterra, like, they're heavy. I don't know the exact weight, I have to Google it, but they're not a light vehicle. So when you have a smaller V6 against a 3.3 liter and single over cam, it doesn't breathe well from factory. You're always having to just mash on the throttle to get it going up hills or whatever, right? Or get on the highway, merge on the highway. So with that, you have terrible fuel economy. Plenty torquey motor, like, it performs really well off-road, but it's just not a great highway cruiser for economy reasons. Supercharger helps that quite a bit, gives it the power where it needed to have it, but even then, like I said, it's still a relatively small supercharger. But you know, if you have an Xterra Frontier and you want a little bump in performance, obviously this is better than nothing. You know, initially when I built the Xterra, I opted for a turbo because I'm more of a turbo guy, and it was easier for me to put a turbo on there than to have to, I mean, I guess easy is subjective. It's easy for me, but you know, obviously there's more performance oriented, you know, aspects of a turbo versus supercharger. Superchargers have a parasitic draw as it's spinning, it's in a raw power from the crank. Turbos are free horsepower that basically is exhaust driven, you know, and we all know what turbos do, right? But there are advantages and disadvantages to a turbo and a supercharger, and we'll get to that here in a minute. But just for conversation's sake, here is a M62 on a VG33. Looks pretty cool. So let's go ahead and take it off, and we're gonna talk about the M122. And I have yet to have it mocked up and what it looks like on the this motor here. So we're gonna do that together for the first time. If I can get this off, how about I just pull it off together as one giant pull here. I think the oil cap was kind of presenting a problem. Cool, so bam, M62. Yeah, that oil cap was causing a problem. I think these valve covers need to be swapped. No big deal. All right, so my previous video, I talked about the progress I was making to make an adaptation plate for the M122 onto the factory M62 bottom plate there. And essentially what I did is, you can see here, I welded cut metal, cut aluminum. This is 3/8 thickness here, so pretty thick stuff. I welded on the bottom, not exactly the prettiest welds, but they're strong, and made it work. And I initially had TIG welded this gap here and planned on sanding it flat, which I did sand flat, and there was no cracks, there was no, you know, exposed areas. And when I welded all this stuff, the metal warped, as metal normally does when you weld. So I knew that I was gonna have a problem. And so even after sanding it flat to the best of my ability, I first used an angle grinder with a flap disc and took down the beads of the weld as best I could. Then I used an orbital sander, which does a good job at putting things flat, but not to like machine level flatness. It, you know, felt flat, it looked flat, but it wasn't perfectly flat. But I knew when I dropped this off at my machinist to have him surface it like you would have, you know, surfacing a head or a block, that he would probably expose the, you know, the gap here. So my initial thought was, well, after you do that, I'll just hit it back with the weld, and that was a stupid thought process because it's going to warp again. He told me, you know what, you did such heavy beads on the bottom, and this is only going to, you know, only need to hold the weight of the supercharger and only hold back a few pounds of boost. Just use RTV. It'll fill in there. It's gonna be fine. Don't sweat about it. And I believe him. I'm with him on that, so it's fine. But as you can see here, it has a very nice mirror-like finish, very smooth. Very happy with how it turned out. So we're gonna do the same thing as before. We're gonna go ahead and get things mocked up here and see how it looks like. And again, I haven't done this yet. When I got this plate back from the machine shop, I just put it here and haven't really done much with it. So I went to the hardware store and got some bolts because I didn't have much, you know, of new bolts to mock it up. So we're only gonna do a couple bolts here. I'm not gonna go through all of them. There's some, you know, motorcyclists outside kind of making some noise. Let me grab the washers, just 2 washers that I need. All right. Hopefully these aren't too long, but we'll find out together. All right, because when I specified the length that I wanted, I counted for a lock washer. I'm not gonna put the lock washer on right now. So hopefully it's not gonna be too long. I'm kind of worried about that and bottoming it out, but we'll see here in a minute. If not, I'll just stack some washers. Yeah, too long. Too long. Okay. So we'll just stack some washers real quick. And I think if I'm looking down those holes, there's some gunk down in there, so I might need to get a tap and chase them out. But let me get some old washers here that I had when I was using to mock things up. And we'll just kind of reduce the height of those bolts that way, just for mocking up purposes. 3 should do it. Yeah, we'll do 3. All right. Okay. Good. Now it's tight. Good. All right, so check this out. And I won't use these new bolts. I'll use my mock-up bolts. I don't want to, you know, get the things ready yet, you know. All right, so let me grab those real quick. I'll just grab 2 like I did at a time. I'll just grab 2 washers and some nuts here. And I have some screws for the throttle body. Okay, so let's go ahead and get this on there. And I want to be careful because I don't want to scratch the new plate, you know? I just want to get things mocked up. So there it is. Put one there. And I'll put one back there, and that should be good enough for today. Put a nut here. And I'll put a nut back here. Kind of just get things holding in place for us. Let's grab a wrench. Okay. Okay, so that's on there mocked up. So normally on the M122 for the GT500, you know, the Mustang, this is the throttle body elbow that they, you know, put on there from factory, and you know it goes just like this, like that, and you have the throttle body that sits right here, and then I think there's an air box like over here, so it just goes like that. So the challenge I had initially was finding, like, well, how do I put a throttle body? On the Ford, they're all drive-by-wire, not drive-by-cable, and I want to use drive-by-wire, or on cable, sorry. But the throttle bodies, they have 2 butterfly valves per throttle body, and that's fine. It's just, I didn't want to do that, and even then, if they did have a dual, you know, the throttle body that was drive-by-cable, I probably would have gotten it and just did this, but there's not. So I had to somehow think of a way to accomplish getting the throttle body elbow, if you will, on there. So let's put this back. So I made this, and this is for a Mustang, actually. It's actually for it's from CX Racing, believe it or not. They get a lot of criticism, but they think outside the box. I kind of give them credit when the credit's due. But this elbow is to provide a hard elbow for like their intakes with their throttle bodies, and it just so happens that it's the same port as the supercharger, just so happened to work. So I made this flange myself, and I TIG welded the it's not a bad weld, looks pretty good, and I welded this up here. So what we're going to do is just get this mocked up by 2 screws here. I actually have the bolts I'm going to run in the bag, but I'll put them on when I'm ready to put them on, but for testing purposes, we're gonna just kind of loosely screw it in there. These screws are actually server rack screws. So, you know, I'm an IT guy, I'm an IT manager, so I have these kind of laying around, and it just so happens to be the right thread and length. So it's great for mocking supercharger elbows, I guess. So there is that, and it fits perfectly. And the throttle body I chose is the LS 92 mil. I'm going to be running Mega Squirt, so I can literally run whatever throttle body I want, and these are a dime a dozen essentially. Air regulators right there, and then obviously it's a single linkage for the throttle cable, so I won't be having cruise control, which I don't care, and that's your typical 5-volt sweep GM style TPS. Now what's in here is just a bag I have, a little Ziploc bag. I can open it. What these guys are, there's 4 of them in here. These are just aluminum standoffs for what I need to put for the bracket for the throttle cable. So I'm going to weld those like right there and get an L-shaped bracket to hold the throttle cable. I just haven't got that far to know where I have to measure the throttle body, I'm sorry, the throttle cable link, the measurement, the length of it, to see where I need to weld it. So haven't got that far yet, but at least I got these, you know, ready to do when I'm ready for that. So we'll just put them back in the baggie so I don't lose them. All right, so as you can tell, I welded this in such the kind of similar angle as the factory. You know, it kind of comes out at 90 and does a 45 down like that. So that's exactly what this is. It comes out at 90 and I have a sweeping 45. Now I realize that I may have made a mistake already with this not dropping down lower like this one does. So I'm hoping that's not an issue. I don't think it will be. Matter of fact, height to height, maybe you can see this, the M122 actually sits a little bit lower than the M62. Let me see if I can show you that. It's not much, but I did notice it. Let me actually move this out of the way. So if you sit them side by side, the M122 actually is a bit lower. Not much, but a tad. Like right here, it's lower. Like back here, it's the same height. You can kind of see how it kind of ramps up like that. But anyway, my point is, if there's a hood clearance issue, I might be okay with how it is. But if there is an issue, I'll just have to cut and kind of re-angle things down a little bit. Maybe take a V-cut and angle it down. Whatever. I'll get there and figure it out. It's not a big deal. So, but otherwise, this is your cheap eBay 92 millimeter LS throttle body. In the wide body here, I have another cheap eBay 102 or 104, whatever it is, throttle body from LS, and it works great. So it's, you know, basically the same thing. The reason why I didn't want to do a 102 or 104, whatever it is, I didn't want to go too big. 92 was actually almost too big for this to begin with. I really would have preferred like an 85 or a 90, but it's fine. It'll work out just fine. But let's go ahead and get this on here, as awkward as it may be. Let me actually take this back off. I don't think it's going to be easier with this like jabbing my stomach. So I'll put that on when it's mounted in there. But again, this will be the first for me to see the M122 mounted on the VG33. You're going to see it together for the first time. It's pretty cool. The weight is like pretty similar, to be honest. It's a little heavy, but it's not like dramatically heavier. So let's get that throttle body. All right. Here we go. Those 2 screws. And then we will try to see what it looks like. Oops, drop that screw. All right, we'll see. There we go. Sorry about that, guys. I wish it just worked out better. But anyway, check that out. M122 on a VG33. And in my Xterra, by the way, it was initially a VG33 naturally aspirated, which had, you know, the pistons being at 9.0 to 1 compression ratio. I blew the head gasket when I first turbo swapped it, and it scored the piston walls on the bores for cylinders. I think it was, you know, on this side. So these are 2, 4, 6. It was on 4 and 6. The firing order is different on the VK, kind of always throws me off. But yeah, so I had to take the engine and get rebuilt. So we put some new pistons in there. We might as well have put we went with the VG33 ER pistons that were coated. So all intents and purposes, what's in the Xterra now is a VG33 ER ready for, you know, boost. Compression ratio, I believe, is 8.3 to 1. So it's a little less compression ratio, which means you lose a little bit of power, but, you know, obviously with the supercharger, it makes up the difference. But yeah, I mean, check that out, guys. That is freaking sweet. M122 mounted on the VG33. That is pretty cool. Again, I think this throttle body, I'm gonna have to cut it down and fix the angle there, but no big deal. Yeah, that's the turbo manifold from the Z31. I use that to mock up relocation pops. But this is freaking sweet. Oh, in case you were wondering, yeah, there's gonna be an issue with the distributor. I'm gonna be running Mega Squirt, so I'm not using a distributor. I'm gonna be using LS coil packs. So yes, this would not work for your distributor fire VG33. 100% no, it will not work. But like I said, I'll be running coil packs from the LS as well. So no big deal. But I wanted to, before I forget, when I had initially mocked this up, like after I hand sanded the plate down, I could not, after like getting all the 10 bolts, there's 5 on each side, bolted down just, you know, like, I don't know, 20, 30 foot-pounds of torque or whatever low, I could not spin this by hand. It was like locking up because the plate, this lower plate that I welded up was so warped from the welding that when I bolted everything down, it actually like tweaked the supercharger where the rotors wouldn't spin. I was like, holy shit, that's not good. So that's why I decided I got to take it to machine shop and have them surface it, and they did it, no problem. They said it was obvious that it was warped, but they didn't have to take off much to get it flat. But I mean, we're good. And in case you were wondering, kind of should have said this earlier, pulley alignment, I did use 3 mechanic straight edges and got to where the pulleys are identically lined up perfectly where they need to be. So this right here, starting at this edge right here, is exactly where it is here on the VG, you know, the M62. So I'm good there. I'm not worried about pulley alignment. I know I got it straight on, or where it needs to be as far as offset. The only other thing I need to concern myself with is on the Coyote 5.4 V8 that they have this supercharger on with, they use a 7-inch diameter crank pulley. And this is oh man, I had this all in my head at one point. This I think is like a 3-inch, yeah, 3.1 or 3.2 inch diameter pulley. On the Xterra, again, I should have written this down. It's like the crank pulley is 6.2 inch, if I remember right. Yeah, 6.2, and then this is 2.3 inch. So the challenge that I have is I'm going to be running the Xterra supercharger pulley, the crank pulley, you know, down here, and that's going to be, you know, the 6.2. But the concern I have is with this being now considered underdriven, how much boost have I lost? I don't know. So I found a company called Department of Boost, this guy with a one-man show who builds, you know, aftermarket setups for the M122 for Ford guys. And he has a pulley setup with a hub that you can easily remove the pulley, that I can go up or actually down quite a bit on the pulley size. And it's cool because it's like, once you get the hub changed out, you can, you know, configure what size diameter pulley you want just by unbolting and bolting on. It makes it super easy versus the press fit that Eaton typically does with their M series superchargers. And what's also cool is that the rib count on the M62 is a 6 belt rib count. This is a 10, and his pulleys, you can ask for a 6, 8, or 10 belt. So if I get to the point where I need to reduce the size of the pulley to better match the crank pulley setup, I will for sure get the 6 rib and have everything look like perfectly matched and perfectly suited. But I don't want to just do that just for the sake of doing it. If I do get a pulley, it's because I need to accurately, properly size the supercharger pulley to the crank pulley. I don't know yet because we're not quite there yet. So I'm going to hold off on buying anything until it gets to that point. So anyways, so that's all cool discovery. But the as far as the timeline and ETA of what's next, I need to get fuel injectors. I tried getting, these are funny. These injector rails right here are from the Mitsubishi 3000 GT. And the reason why I bought them is because way back in the day, like in the early 2000s, before everyone was getting these billet fuel rails that are available for the Z31, this is what we used to run for aftermarket fuel rails. This was it, out of a 3000 GT. The ports are exactly the same to that of a VG30 and obviously a VG33. So we would make this work. We'd have to make some custom, linkages here to bolt it to the lower intake. Actually, I can show you. So you can see that the ports for the injectors, bam, 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 they're exactly the same. But the mounting positions were not the same, so we have to make some L brackets and bolt it down. But this worked way back in the day. And the reason why I bought this to see if it would work for the M62, or I'm sorry, the M122, it was to see if I can get away with using top fed and fuel injectors to get away from the Xterra side fed injectors. On one side of the supercharger setup, we're going to use this for mocking up. I can totally use it, right? I could totally use top fed and fuel injectors on that side. But on this side, because of the kick out that the bottom plate does, it doesn't allow me to put injectors in there and be able to, it's actually specifically right here, it presents a challenge. So I can't use these. So that only limits me to running Z32 injectors. They will work. You have to kind of modify the top mounting bracket that you do for those injectors. But there's a company called AUS, and they make, resize injectors all the way up to 1200 cc. So I think they do like 500 or 600, 750s, 800s, and then 1000 and then 1200. I'm kind of rattling off sizes. I know they do incremental sizes. I might as well go to the biggest size. It's never a problem to have too big of an injector. You just tune accordingly. It's nice to have that overhead. So I'll probably end up getting those injectors. They're like $600-700. Get them to work on the VG33 lower intake. And then from there, I just need a fuel pump, which I'll probably go for like Walbro 450, and then Mega Squirt. Get that all wired in and get that going. And that's essentially it. Like I kind of have everything. The only question from there is I'm debating if I just change out the turbo. I don't want to go too large of a turbo. Like right now, there's a T3, T4. I'm kind of thinking like a 58 millimeter, like a 58, like 5.8, I think that's what it is from VSR. So that's probably what size I'll go. But yeah, I think that's basically it. And then from there, it's just tuning. So the ETA timeline is, I'm looking at roughly $3,000. Wife wants me to kind of carefully budget this. We don't need to be pointlessly throwing money at this aimless project. I'm just doing it for fun. So I guess when I get my tax returns, I think that's when I'll do it. But that's basically it. So I think, give me a couple months. It's not like it's a hot pressing item to get done, this twin charger setup. But yeah, that's kind of where I'm at. Trying to think of anything else to say. I don't know. I think that's kind of it for now, but this is cool. This is the first time I've seen an M122. I keep saying that. An M122 on a VG33. That is freaking sweet. So anyway, guys, I think that's it for today. I have to kind of disassemble everything and put things away and go from there. But this is cool. I'm kind of excited. I hope, I hope you guys, Xterra owners or VG33 owners or even Z31 owners, maybe this inspires you to do the M122. Like after I get it running and if it yields great results, hey, sky's the limit, make what you want and go after it. I'm a turbo guy. Don't get me wrong. Turbos are great, but I think it's just cool to do something different and do a supercharger And in my case, I'll be doing supercharger and a turbo, you know, turbo fed into the throttle body and do a twin charge setup. On my last video, by the way, before I let you go, a comment was made to me saying, hey, there was like a Nissan Micra, I think that's what it was, that actually did this. So I did some research, and sure enough, they basically did exactly this. They had a root style supercharger and a turbocharger feeding into the throttle body and doing that. The only difference that they did is they had a magnetic coupler that would disengage the supercharger to basically quit spinning, and the boost would come from the turbo. But I'm going to do both. I'm going to compound the boost. So if the turbo is making 7 pounds of boost and this is producing 7 pounds of boost, it'll be 14 pounds of boost. And it does actually mathematically work just like that. I guess the one thing I'll say real quick, as far as the bypass valve that's right here, I did figure out how I'm going to do this. Not to get too complicated and where I want to drop the video right now, but there is a solenoid valve. It's actually right here. So before I say it, normally this plumbing from the bypass valve feeds into the lower intake, and you know, basically when it's not making boost, the bypass valve will open, allowing naturally aspirated air, you know, normal air, vacuumed air to come into the intake, putting less of a strain on the supercharger rotors. I still want to take advantage of that, but when you have a supercharger, or I'm sorry, when you have a turbocharger feeding pressurized air into the intake, you're gonna have a problem doing compressed air that's gonna hurt the diaphragm, and you're gonna blow out the seals in the diaphragm. So what I've done some research on how to accomplish it, and I kind of had to rack my brain on that, is using this solenoid valve, which has an atmospheric bleed release right there. This is actually the same valve that's in the wide body for the variable valve intake runner. So on the wide body, there's an actuator. It looks just like this, but it has a linkage on the back here, and it'll open from long runner to short runner based on the RPM threshold. So we did on the dyno tune, and we saw roughly a 70 to 75 horsepower gain just by intake tuning, which is insane, but it has this valve to open and close that accordingly, and it works. So using the technology and principles from the VK45 intake, that's on my VK56, I'm gonna apply that principle to this setup and essentially have an external storage tank for vacuum with a check valve so that it'll never see positive pressure, only vacuum pressure. And through Mega Squirt, I'll be able to open the solenoid and close it accordingly so that this will work properly. So that's my plan, you know, not to get too technical, but it does work obviously because I'm doing it on the VK56 over there. So that's what my plan is for that. But otherwise, guys, I'm gonna wrap it up today. Pretty excited that I've made this progress. And again, I know I can put a bigger turbo. I know I can just crank up the boost in the Xterra and make more power. But I just like doing things differently, and just to make people's brain twitch a little bit because I did something different. Like on the VK here for the wide body, I know I could have done LS, you know, but I want to do something different. Or on the 89 here with the 800 horsepower VG33, I could have put an LS in here. Like, I get it. There are different ways you can send a cat, but I'm just trying to do things differently and do things unique because, quite frankly, like, how many LS swaps are out there? There's a ton of them. Or how many high horsepower VGs do you see with a turbo? A ton of them. But I just want to do things differently. Yep, I'm going to put a big ass supercharger, put a moderately sized turbo on it, and let's see what happens. And if it doesn't work the way I think it does, and if it's a total failure, I'll be the first person to say, oops, I screwed up, I failed. Let me take this off, just stick to turbo, and maybe I'll sell the M122 so that someone can upgrade on their Xterra Frontier just to go to a larger supercharger. I don't know. But right now, I think I got all my eggs in the basket correctly, got my ducks in a row, where I think this is going to work out just fine using the, you know, the compound or twin charge setup I'm thinking through. So anyways, let me know, you guys, what your thoughts are. Drop a comment in the comment section below. Like and subscribe as always. Share to your friends, family, and friends, whatever. But I think I'm making good progress here, and we just need a trip on a brick of money to wrap it up. But otherwise, that's it for today. Like I said, I will be dropping a video tomorrow for this car, wrapping this car's project up. So, all right, guys, I think that's it for today. Hope you're having a good one, and we'll chat later. Take care.